So I have the privilege of chairing, the task of chairing this first session that, as you see from the agenda, is dedicated to the service providers and network operators' views and perspectives. As a matter of fact, we are witnessing a growing interest, not only in the US, but also in Asia and even in Europe, on lab activities, pods, plans for the future. So we believe that this session is a good opportunity for us to start sharing opinions from service providers in Europe about potential common interest and eventually potential synergies. So as you see from the agenda, we have three speakers for this session. The first one is Peter Feil from Deutsche Telekom. The second one in the list is Stefano Fogli from British Telecom and Paolo Fasano for Telecom Italia Mobile. The speakers have 15 minutes each for the talk and then 5 minutes for question and answers. Okay? So I'll stop here just to save time. I'm leaving the floor to Peter. Would you mind coming to the stage, Peter? Thank you.
Yes, thank you very much. Okay, good. So my name is Peter Feil. I am with Deutsche Telekom Innovation Laboratories. So this is a central R&D innovation unit of Deutsche Telekom Group. And I emphasize it's Deutsche Telekom Group. It's not only the German part of Deutsche Telekom. In the meantime, we are making more than 50% of our revenues outside of Germany. So especially in Southeast Europe, we have a number of subsidiaries. And I very much like this picture because it tries to show the overall picture, basically putting all the interesting buildings of the countries where we are present on one slide. So before I go into my presentation, and I try to make it short, maybe to save some time, I would like to emphasize that this is not my presentation. It's basically a collection of slides from different presentations which other colleagues have put together, mainly Axel Klauberg, my colleague in the CTO department, and Manuel Paul, who is also joining this workshop here. He is active in our standardization group. So let's go to the first slide. So this session is also about requirements. And so what is our vision? This slide somehow tries to explain where we think our way should go. So we all know there's a lot of competition in the telco market currently. We compete more and more with OTTs especially. So we need to be able to provide our services more cost efficiently, faster. We need to be especially more dynamic if it comes to providing new services. And so there are three pillars which are described on this slide, which we think are the key to achieve this. So the first thing is cloudification. So we are heavily investing currently in moving the traditional telco services into the cloud. So we are just starting to do so because you can do almost everything in the cloud today, but not with the reliability that we are used for our services. So the carrier grade reliability, that is something that we are still working on. And the second pillar is, okay, you don't see the slide, okay. The second thing is that we are also betting on IP. So we try to get rid currently of all PSTN, ISDN, and so on technologies in the next 1 or 2 years, and everything should be delivered over IP. And you may have heard of this TerraStream approach, which is a very simplified, high-speed IP network architecture. And this is something we try to implement currently in our production networks. Then the last thing, but maybe also very important, is the SDN part of all of that. So the management, the provisioning of all these services we think that this needs to be done using SDN philosophy in general. So, and where are we today with this? So, as I mentioned before, Deutsche Telekom Group has, if you will, three big parts. The first one is T-Mobile US. That's a very independent subsidiary of Deutsche Telekom. They are doing more or less their own stuff. Then we have Deutsche Telekom in Germany, which is a special case because we are the old incumbent in Germany. And the third part is our NatCos, as we call them, our subsidiaries in Southeast Europe. And there we have the following situation. We have around a dozen countries where we are present. You see the magenta countries here. This is where Deutsche Telekom is present. And we have currently a very heterogeneous environment. So every country has its history and their own service platforms, their own marketing. So everything is currently running on a very local, national basis. This is not very efficient, as you can imagine. It's very costly to keep this running. So we have started, so basically we have implemented already a lot of this. I will come to that in the next slides. And we are trying to implement the philosophy I presented earlier, first of all in these Southeast European countries. And this fits very well to the Deutsche Telekom big strategy. You can see on the left-hand side, this is what our board of directors presents when they do any speeches on conferences. And how does it look like? Well, this is again a little bit to explain why we are doing that. We have historically grown production platforms, and we are trying to implement now one integrated pan-European network using NFV, SDN technologies, and well, this Lego comparison is always nice to use. So basically, we are trying to provide the basic services out from a common infrastructure, and then the national add-ons can be done locally because we have different different languages, we have different cultural backgrounds, so we need to adopt on a local basis what we are offering. But the basic services can be provided from one common platform. And again, this is the footprint where we are. And go a little bit faster. So, oops, disappearing. No. Okay. One back. So we are currently. Okay. So you see what we are implementing today. So we are just setting up data centers. So we have two categories of cloud data centers, infrastructure data centers. We have front-end and back-end data centers. So we have basically for the local needs, we have these front-end data centers where the local service adaptation is done, and it is not planned to have any customer data, for example, there. So and then we have three big data centers, the back-end data centers. One of them is already up and running in, I guess it's in Hungary. So we will have three of them very soon. So this is all now being set up using technologies like OpenStack and so on. So I will not go too much into the details, but we are also using open source software in these environments. And these three big back-end data centers are meant to serve all the countries with the basic services. Because, for example, up to now, if you look to Bratislava, for example, Bratislava is just half an hour drive from Vienna, and it doesn't make sense to have a data center in Vienna and one in Bratislava. This can be done from one site. just as an example. And exactly this is what we are doing today. And you may have seen this slide before. This is just a summary of the so-called infrastructure cloud that we are implementing in these data centers. So we are trying to put all services into the cloud. This is not so easy for databases, for example, Oracle databases. Up to now, we don't have a solution. But as time advances, we see more and more of these services that can be produced in the cloud. So the different colors here show the different sorts of services that we are trying to provide out of the cloud. So the blue ones are basic network services like DNS, or as we are trying to run an IPv6 network only, also IPv4 is a network service for us. So we have to do the translation from IPv6 to IPv4 also in the cloud. Then the typical telco services, IMS, video, and so on. These are the magenta colored ones. And we are also thinking about putting third-party services into this cloud. This is the yellow part. So we are not there yet, but of course this is something we would like to do. Services like CDN services from third parties, why not put them into the infrastructure cloud also? Good. So I used some of these slides to explain our strategy that is now first being implemented in Europe, but I would also emphasize a little bit where we are active to come to this goal, because SDN, NFV, and all these cloudification efforts are still not that mature, I would say. So I personally started with SDN 10 years ago, before SDN was used as a term, collaborating with Stanford University in the Clean Slate program, where OpenFlow was basically invented. And as we see, it's very important to be in the community, to see where the journey, into which direction the journey goes. And this is just a short overview, thanks to Manuel, who has done this slide, to show where Deutsche Telekom currently is active in this ecosystem. So the traditional standardization bodies are still important, but of course we see new fora, new collaboration groups coming up that are becoming more and more important. So the traditional way of standardization, as we know it from many years ago, this is still there, but it has to be augmented, if you will, with the efforts in the open source community and so on, because software is becoming more and more important. So running code is what we want to see, not just standards, and maybe 10 years later a working product using these standards. And so as you can see here, we are active not only in bodies like ETSI, ITF, and so on, but also in the OpenStack community. There we have a group of people who are actively contributing. And I would like to emphasize especially the ONF. I was active in the ONF from the very beginning. They are just celebrating their fifth anniversary, so 5 years ONF. And the ONF is currently also in a big transition. So 1 year ago, we have decided in the board of the ONF to put more resources into open source software developments. So we have official partnerings with the ON Lab, for example. The ONF and the ON Lab offices are in the same building in Palo Alto, so this is quite natural. And the MEF is also a very important body in that area. With IEEE, we are also collaborating. So a lot of things are happening here. And we as Deutsche Telekom think that we should continue to actively contribute to these bodies. And so this is why I'm quite happy to also have the opportunity to speak here at this workshop. And my last slide. So this is just a short sketch. Also, Manuel put that together, which shows that in the last 5 years, a lot of things have happened in that area. So on the left-hand side, this is the architecture we showed 5 years ago when we started with the ONF. So it was very open flow centric. So it was just the separation of forwarding and control plane. But obviously that was the key idea behind SDN during that time. And of course, this has evolved a lot. NFV came in the meantime, and now we have a more complex SDN architecture, which is more holistic, I would say. So we are looking much more into northbound interfaces, into the service level, but of course, even on layer 0, layer 1, the SDN philosophy can be applied now, and this is important. So we really believe in this architecture, in this model, in this philosophy, and I think the time is really right now to put that into operations. So during the last few years, it was more an academic exercise, if you will. We could do a lot in our labs, but now even our CTO has embraced this idea, and I see many other telcos, AT&T, Verizon, also in Europe, a lot of telcos are really betting now on this technology. And so I think it's really important that we join forces to make the best of this technology, of this philosophy, also in Europe, not only in the US. So I'm quite happy that we have the opportunity to talk with our colleagues of ON Lab here, more from a European perspective. And yeah, let's enjoy this workshop. So thank you very much.
Time for questions. Are there any questions from the floor, please, for Peter?
I mean, I'm available the whole day, so if anyone has questions later, just come to me. Thank you.
I can make a question just
okay.
to break the ice.
Yeah.
Okay. We know that SDN and the evolution of cloud computing towards the edge computing and eventually the fog computing are potentially introducing flexibility, programmability, the chance of optimization of the resources, and a number of potential advantages. There are pros and cons, obviously, in any transition, radical transition like this. My question is, well, it's a big question, but maybe you can just elaborate a little bit and maybe we can discuss offline. How would you see the evolution of the control, management, and orchestration capabilities in view of the complexity which will be introduced in the network? Because it's likely that in the future we will not manage pieces of equipment, closed pieces of equipment, but a huge number of software processes intertwined with each other and dynamically allocated and moving into the production infrastructure. So in my opinion, but not only my opinion, the evolution of control, management, orchestration is the key point, the Achilles heel of the story. Could you elaborate a little bit about that? It's a big question, but I think we can discuss offline and during the workshop.
Yeah, I mean, what we see today is that there is no solution available currently regarding all these issues. So if you buy a product from a vendor, they offer you their orchestrator, yes, and this orchestrator is very nice to use, but only for their pieces of equipment. And usually today, what we are implementing in Europe, we are doing our own thing. So we do not use an orchestrator that is available on the market. So we have to program a lot so that the solution that we use fits to what we need. And there is a big gap currently between orchestrators for the infrastructure and for the services. And these things currently do not really fit together. So there is still a lot missing. And what is clear, if we introduce this new world, it's more complex. It's more complex, it's more software, we have additional layers, but we hope that by automation we can be more flexible, more efficient, and this automation is a key. And of course, we may introduce more pieces of self whatsoever. So artificial intelligence may be that a number of management issues are solved from artificial intelligence automatically, so that the human operator only needs to intervene in extreme cases. So, but it's still a long way into that direction. And also, I mean, we are all engineers. I think most of us are engineers and technical people, but also the human resources aspect of all that is quite important. So we need different skills. We need to reorganize our companies, because up to now we had one department who was responsible for the access boxes, another department for the aggregation boxes, and so on and so on. And this is disappearing in the new world. So DevOps is a keyword you hear everywhere. We need more DevOps that are able to run these networks, but also to improve, to adapt. And it's still a long way to go. And also innovation, the way we do innovation is changing. So in the past, we had our innovation labs, our research unit. They developed something, then they handed it over to production, and they did then something different sometimes with these technologies. Now this is more and more coming together, and also IT and networks. This is, you cannot distinguish anymore. It's one thing, and it's a big change, digital transformation, some call it. But I think we have to go that way. Otherwise, we will not be able to serve the requirements of our customers as they are used to get it. Yeah, different question, but not a very short answer. Okay, thank you.
Any questions? British Telecom. So, Stefano, would you mind coming to the stage, please?
Okay. Oh. Okay. Good morning, everybody. I'm Stefano Fogli. I am the responsible of NGA architecture in BT. And well, I liked very much the last slide from Peter talking about programmability, because this is also the keyword that in British Telecom we do use for, in general, for the concept of virtualization. So this is what I'm going to talk about today. Basically, as this workshop is based on CORD, we have tuned our presentation especially on the disaggregated switching into the central office, which for us is, as you will see, a very key part. Anyway, we will discuss also about the network programmability concept within British Telecom. So, okay, our ultra-fast program vision, I'm not going to spend too much time on this slide, just to remember that we have very recently pioneered the G-fast boosting, let me put it like this, to hundreds of megabit on kind of long loops, like 300 meters or the like. And we have an ultra-fast program that aims to reach 10 million homes and smaller business by end of 2020, plus 2 million homes with FTTP. Our network, of course, is, as you probably know, separated functionally. We have a division which is OpenReach, which through the central office has to deliver all the services, active and passive, in a completely fair and non-competitive way between all the CPs, not only to BT. So the role of central office for us is absolutely key for the strategy not only of British Telecom but for the whole of the UK. So is a stronghold of our competitive model. Let me put it like this. I will come back to this point. So just a few words about our last mile and our ambition. We call it NGA2 because there was an NGA1. Actually, there is an NGA1 which serves up to 25 million premises in 2016. Just to put it into perspective, we are talking about more than 90% of the UK premises can reach today a super fast service, where super fast means from 30 megabits onwards. We want to go to ultra fast, which means in the UK terminology more than 100 megabits for every home. By 2020, like I said, 10 million homes plus 2 million with direct fiber. So as you can imagine, a lot of connections, a lot of speed, a lot of burden onto the open reach handover point. Let me come back on this point. So this central office is, again, as I said, a very key point and is, from our perspective, from our calculation, is going to skyrocket in terms of connections, bandwidth, and importance for our network. So that's why we are very much interested into the CORD project and into what the Americans are doing, because we think that it is right to put the focus of innovation on the central office in the end-to-end network. A little bit on the programmability concept. As you see, BT is like other operators following closely, implementing, I would say, the whole set of virtualization functions. We have on the right of this slide, you can see our pillars, technology pillars, which are NFV, SDN, SD1, Agile OSS, very much used word, unfortunately very, very difficult to implement, I would say, and the white box switching. I have one slide specifically on the SD1 concept, which is a new service that BT has launched worldwide. Why focus on that? Because it encompasses very well our concept of programmability. Basically, we have already, as you probably imagine, a business VPN service, which is, let's say, fully featured based on MPLS layer 3 VPNs, which works well, but of course it's cumbersome for the enterprise. We need to send our technician to install the CPE and so on. So, but also very full of diagnostic, a lot of tools, but again, high price, high-end service, and kind of difficult to be installed. So with SD1, we wanted to address a different market, let's say. So basically what we do is a very simple service based on programmability. We send the CPE to the enterprise. It is hopefully self-install. So this connects in a very simple protocol stack. It is just IPsec over the internet to our central server for the SD1. In short time, this central server will be integrated with the BT cloud nodes, so that it can also interoperate with the I1, which is the MPLS-based VPN. So all of this to say that in a very near future, an enterprise can choose which branch to connect with which technology. For example, the central premise can be connected via an I1, so a fully MPLS-based wide area network, while all the other branches, or some of the other branches, in order to reduce cost, can be connected via SD-WAN. It is something that, again, leverages programmability, because there is today a business portal that programs the SD-WAN. Today, as you can imagine, the number of things that can be programmed are a few, just based on basic routing, security, firewalling. In the future, we would like to integrate this with virtual CPE concept in order to download apps and maintain apps directly on the CPE. So everything, as you can see, is very much evolving, but the concept around the concept of programmability. As you have seen in the previous slide, the white box switching is a pillar of our network, our future network programmability. Not only for the whole network, because again, with white box switching, we are talking about using commodity hardware and off-the-shelf switching software in order to achieve some benefits. This is, in theory, true for many parts of the network. Again, we see it especially for the access part, for the central office part. So what are we doing for a central office? I'm sorry for Mauro that has to see again this slide. But this is what we have presented in Atlanta in the CORD symposium hosted by the Broadband Forum. Basically, if you decouple the network OS from a white box layer 2 switch, which again is based on commodity hardware, there are some advantages, also some disadvantages, to be sure. And this is what we are at the moment studying in BT Group. Again, it has to be BT Group because there are several positions in the network where you can apply this concept. One of those is the OpenReach one, so is the access part. In the access part, basically we see some specific opportunities and specific challenges. So, of course, the opportunities are the promise of an overall cost reduction, a huge scalability, which is today what we are worried about, honestly, to be constrained in shelves instead of being free to act as in a data center, for example, just stacking pizza boxes and connecting on demand. The fact that, in theory, this should be an open environment which should facilitate the service programmability and simplify the operational model. Again, in theory, we need to understand that. As you can understand, also there are challenges. First of all, well, I would underline the first one. We need to respect the regulatory boundaries. I will come back with my speech and my talks in the 2 days again on this point because CORD is great, but it is, as it is today, it is not applicable to Europe, I think, because there must be a strong focus on respecting the regulatory boundaries. And I'm not just talking about BT, which of course is heavily regulated and separated, but also the other ex-incumbents in the Western Europe are heavily regulated. So again, there must be a regulatory boundary to be respected here. Again, there is, of course, the point of integration of many different vendors, also a different purchasing process, just to be simple, is not simple, again. And so what are we doing in BT on this? We are investigating in a, I would say, subdued way, but not, but anyway, with a lot of interest. The CapEx model, we are validating the networking functions, a very rough management validation, and we are very active in mapping the vendors and the other community, means the whole industry role with respect to this technology. More in detail, what are we doing today in our labs? We have dried up our huge number of features that we have in the today central office, well, in the tomorrow central office. we have consolidated the most important ones into these 5 pillars that you can read here. To be honest, I believe that one or more of these pillars can apply also to other Western European operators, and kind of especially the first 2, I would say, but also the fact that we have to implement a very sophisticated and very fair QoS model, and we need, let's say, the white box switching technology to come after us. And as you see, the typical testing configuration is a cell, if you want. This cell can be replicated a lot of times to mimic exactly what we need into the central office. So as a preliminary result, I would say that the switching OS, which was built for data center, seems to show a good flexibility to readapt to our request, and in short term to evolve to what we really require. So this is encouraging. This needs to be tested again. This needs to be, looked at with the devil's advocate stance. So we cannot say at the moment that we are going to, well, either deploy or I would say hard testing or field trialing this technology. It is still early to say that, but again, it is encouraging. I can disclose more details in these 2 days. So as a last summary, again, we are very much attached to our ultra-fast broadband program. Programmability is something that will be very true for the whole BT network, from global services to the access network, and it is leveraging on SDN and NFV. SD1 is a technology that we'll strongly believe in, and we are investigating the feasibility and the economics of a white box approach in the whole BT network, but in particular for the OLT. The OLT being, of course, the access line terminal that you've seen. The early results encourage us, so we are also willing to share them and willing to cooperate with other operators across Europe. That's all from my side. Fire away.
Stefano.
Cheers.
Any question, please, from the floor? Yes, please.
In the ultra-fast broadband networks, the quality of service algorithms, in your experience, do they play a critical role still?
Yes, absolutely. Remember that we are heavily regulated, so we need to be fair across a whole range of CPs, right? So we need to ensure that every customer coming from whoever, so Sky, TalkTalk, BT, is treated exactly the same way. So basically, our concept is, of course, the one of being the policeman, if you want. We have to delegate to the CP the shaping of the traffic. They have to shape the traffic, but we need to control. So at the very beginning, when the traffic exactly enters into our layer 2 switch, there is a policer for each end user. And this policer, as you can imagine, has to, compare the traffic against the committed rate and against the peak rate. And we are audited, by the way, so that this algorithm behaves exactly in the same way for everybody. In future, if I can say that, we would really like that the virtualization can bring an innovation also on this point, because in theory, today, what the CP do in order to activate their QoS is, well, they have to ask for a stacked VLAN ID to OpenReach, then there is an answer, then they have to fill in a form. I mean, is, I would say, a digital/manual process which takes time. We would really like to see if in the future this process can be automated so that every content provider requiring a connection from for every one of its end users can instantiate that with all the policers and so on in a programmable way in minutes. Okay, this is well, I wouldn't say that we are studying that because we are still this is still in early phase, but personally I would say that it is very interesting. And
thank you.
Yeah, again in this point, Mauro Campanello from GAR. I think that you need these policers and shapers only when you have congestion. That means that you think that your ultra-fast networks will actually encounter a lot of congestion in the network. First question. Second question, how this deals with a newly approved BEREC legislation that actually enforces transparency and tries to avoid that these kind of policies are applied in the network. Thank you.
Okay, the first answer is we are trying to make sure, first of all, that we have a very limited number of congestion in the OpenReach part. We cannot be 100% sure because we don't know which are the BIRAS scalability figures in the content provider networks, but we make sure to have let's say more bandwidth per user than the one that normally it is used into the content provider network. This doesn't assure that, of course, this doesn't prevent, let's say, congestions. In case of congestion, our mechanism is to have a very simple priority, non-priority marking of the frames, so that the non-priority frames, in case of congestions, have a higher probability to be dropped. This is very simple. Honestly, at the moment it works very well. Our statistics say that probably no priority frame has ever been dropped till now. I would say I cannot sign it, but I would say so. Anyway, if you think about the trend, which is increasing the bandwidth per user, increasing the number of users, concentrating them more into one single platform, we are also thinking about adopting a more sophisticated algorithm with different priority levels, not just two, especially for the high priority video, possibly on the internet. Sorry, which was the second question? I totally forgot.
That match with the recent regulations in Europe.
Yes, this is a more generic one, but for us is very important that what is doable for one single content provider can be replicable with the same conditions for the others. So basically, this for the cord concept, I have just a few months ago I've challenged Larry Peterson about that. And he was talking to me about a virtual cord for every customer, which this would be the way. I mean, kind of complex, right? Yes. So that's why, in my opinion, with cord for Europe, we are still a long way to go. Let's say.
Okay, so thanks a lot.
Thank you.
Thank you, Antonio. Okay, so the title of my presentation is From Cord to Team FutureNet. I will try to explain what is FutureNet in the next few minutes. But before doing that, I'd like to say that also Team in this process of evolving its network and its services is affording the transformation that we call the digital transformation of the society and our company. And for doing that, we are already acting at the infrastructure level by introducing into our network so-called NFV infrastructure that are data centers that brought into the central offices in order to host network function that are virtualized and not physical. Obviously, this part is at the very beginning. We started last year. We have implemented a couple of our major POPs with the NFV infrastructures, and we activated, let's say, rather simple network services by the end of last year. This year we are going to add new POPs with these capabilities and to enrich the number of network functions that are virtualized. Obviously, the environment we are taking care now, it's a mixed environment starting from a situation where almost everything was physical, and some of the physical is very legacy. So it's a number of years that has been into the network and operated very well. But we would like to introduce in this framework that is the evolution of the infrastructure also an evolution of the control and management part that enables network automation, because this is the real need that we have been focusing on as team for the evolution of the whole of the operation of our network and services. For doing that, we have been identifying a couple of different views. One from the top that is requiring from the customer-centric view a way of seeing the network services that is a high-level view, quite an abstract view, in order to hide to that level of service modeling the complexity of the network. The second is a bottom-up, and looking from the network should be able to expose toward this layer a very simple view of the network that is not dependent on constraints such as, for example, if the implementation of a certain network function is physical or virtual, or constraints due to different technologies that are applied maybe for routers, for other equipment into the network. This framework is separating network control and management with some more service-oriented, customer-facing part of the control, and interfaces between the different blocks that are highlighted are quite important. So we are in the process of developing this architecture through the acquisition of components that are enabling, for example, network automation within the NFV infrastructure, and for managing wide area connectivity and connectivity between customers and services. But while we are doing that, we are also looking at the future, and the future will bring as a main concept for new things this 5G stuff that is already in the process of being experimented, standardized, defined, and so on. What we have seen about the 5G as a very interesting is the requirements that are put from the 5G point of view on the network architecture about the multi-access integration. So to have a core network that is really access agnostic, independently if it is fixed or mobile, any kind, any flavor of mobile, and so on. And this concept of network slicing that may enable the future management of the network to identify portion of the network that are dedicated to specific services. So, trying to elaborate on these concepts that are within many international projects, many international activities, and so on. What we have done is to define a project within a team that we called FutureNet, that it is really an initiative inspired by CORD, in the sense that the architecture of the central office that have been proposed for CORD has been considered as a starting point for developing the FutureNet. But at the same time, the idea was to build up on the evolution we are addressing for our network, so not to scratch everything from a whiteboard, but considering that we are evolving our systems, introducing NFV infrastructure, introducing elements for network automation, defining the way how to manage traffic within our own network. The point is, the main technologies are the technologies we discussed today, so software-defined networking, virtualization, open source software, disaggregation, and so on. But what we are able to do today, we see it as at the very beginning of the story. There is something that will be much different when all this stuff will come to maturity. And this is what we want to explore with the FutureNet concept, where we decided to blue sky the central office, but in a way that is inside a network evolution path. In fact, the idea is that we should have within our network the different roles of the site of the central offices that are maintained. For example, there is a role for the POPs, what we call the POPs, where the major main service function are present, and what we call the metro aggregation areas. They are not only central office sometimes, they are central office giving access to simpler remote sites where access nodes are present, and so on. Trying to put the CORD architecture inside this picture and the interconnection mesh among the different central office roles bring to new concepts that enrich the CORD model that is single central office evolution by adding to this concept the end-to-end network view. And this is one of the main points that we see as necessary for the evolution of the CORD approach. Not to concentrate only on the single central office redesign, restructuring, and so on, but also to add an end-to-end view of the network. Because from a service provider, the network is the platform. There are services that are not simply offered from a single central office, but are offered, for example, from different central offices scattered around the country. And you should have a representation of the service that is a single one, not split in different components for the access only. So the first challenge we would like to put on CORD is to try to understand if and how to extend the cord concept to a network level. The second point is about control management and layered architecture. So we see that in the control and management part, both static configuration and dynamic configuration play a very crucial role to enable the network automation. Right now, trying to implement the cord approach, it is not clear where certain static configuration are placed into the whole model. For example, when you address the deployment of an access node, a fixed access node, if you have to configure physical parameters and so on, where it is done. It's something that it's not clear to us where it is. But if you don't have a unified picture, it's impossible to reach the goal of complete network automation, because you will have the capability to automate some features, but still to do in a different way pieces of configuration that are taking time and so on. The other thing is that northbound interfaces to our OSS and BSS, and let's not think to OSS and BSS like we see them today, but the evolution of these systems that there will be in the place need to be defined clearly in order to offer this network abstraction to the customer service modeling and management that is crucial to have an easy management of the network. Another point is that we observed that traditional networks were built around a layered architecture. So there is horizontal layers with clear interfaces between them. And the reason for doing that was that you should reach a clear separation of concerns between different groups and organizations, and having a way of specializing people, having a way of making effective troubleshooting, understanding where it is the problem, and giving to the specialist the solution of that kind of problem. We believe that effective troubleshooting should become a main goal for CORD, because this new architecture that exploits a more homogeneous view about everything is software, so there is the possibility for everybody to know everything, seems to be very complex when you afford the troubleshooting phase of your operational activity. So, having said that, there are a number of questions we have put on the table for our OneLab friend and the community that is building things on top of these concepts, trying to understand how to extend and complement the core architecture to encompass the end-to-end network view, if it is feasible to see a hierarchical approach, maybe, and in this hierarchical concept, to understand which are the pieces that should be managed in a hierarchical way. It's at the controller level, the orchestrator level, and so on. Trying to understand this problem of troubleshooting as one of the main things that we have to take into account to develop a new architecture. The need of network automation that include also the evolution of the upper part of the control and management system, and so to understand if CORD as an approach of giving a complete and somehow closed solution, or it has the idea to offer interfaces towards external systems that need to evolve in order to be consistent with the new architecture. And finally, the point of defining a viable migration path. Current experiments we are doing are experiments that are on a revolutionary approach. We change everything into the network, trash everything, and put white boxes, put servers with software, and so on. But that's not an approach that can change a network of a telco in this way. So if it's possible to envision a migration path that starts from pieces to be changed in order to change everything with the time for doing that. So finally, with my presentation, I also introduced a slide that I anticipated to our ONLab friends. That comes from discussions we had, for example, also with Orange, about the comprehension we have about possible collaboration with the ONLab on the project that it is supporting. So we have been hearing about the proposal of the creation of ONLab Europe. What is the status? We still have some questions about what would be the relation between ONLab Europe and ONLab US in order to understand if it is feasible, what are the mechanisms to make a critical mass and to work together on the same project. Understanding the specificity of Europe, but not doing something different from what is done in the US, because otherwise they are projects diverging in somehow. About ONOS, it's quite clear the membership offering that ONLab did, but for example, about the integration of XOS was not so clear in the same way. There was also a question about the different partnerships. So you ask for membership, but also for being collaborators. Is something that is open to everybody to be collaborators, or it's dedicated to specific part of the scientific world? And then about the recently announced Open Chord project. Open Chord members seems to be both partners and collaborators. So what is the policy for being membership for the membership in the Open Chord? These are questions that should be stimulus for the next part of the workshop, I hope, for the session of the last session of today, and maybe also for the discussion of tomorrow. Thank you.